But one of the nice things about Worldwide Telescope is you can use it to make pre-recorded tours as well. So over the past few years, we've had students working on some of these. So I'm going to show you a few of these tours. And these are short, ranging from 1.5 minutes to maybe 3.5 minutes. And we can, if you want to put some comments in the chat, like it's a true film festival, if you want to use those exuberant 1 or 2 word film reviews, outstanding, breathless type of a thing, feel free to do that. But we're going to start actually with some of the more recent work that has been done. And we're going to focus, the first word in the film festival was intergalactic, but that was more of a Beastie Boys joke than an accurate representation of what we've been doing here, because almost all of the tours will deal with the solar system. One will deal with star formation, one with constellations, but all of those things are in our galaxy. So we're going to start with a tour of the inner solar system, and that was done by a student this quarter. So enjoy.
Here we are at the Kennedy Space Center in Florida, home to NASA's primary launch center for human spaceflight. And now we blast off on our mission to investigate the sun and inner planets of our solar system. Here we are at the center of our solar system, housed by a hot ball of glowing gases we call the sun. The temperature at the sun's core is about 27 million degrees Fahrenheit. And that little blue dot on the left, that's about how big the Earth is compared to the sun. Now that we've explored the sun, let's go to the first planet of the solar system, Mercury. Mercury is the closest planet to the sun and has very little atmosphere. Because of its lacking atmosphere, it can't stop impacts and is littered with craters. In the daylight, Mercury is superheated by the sun and can reach 801 degrees Fahrenheit, but at night, it can reach as low as negative 279 degrees Fahrenheit. Mercury is also the smallest planet in the solar system and is only slightly larger than the Earth's moon. Now to the next planet on our mission, Venus. Venus is home to a toxic atmosphere and volcanic activity. That atmosphere traps greenhouse gases, leading the planet to grow even hotter each and every day. The surface of the planet is even hot enough to melt lead. Venus is about the same size as Earth and has a diameter of about 3.5 moons. Now for our next planet to explore, the planet we call home, Earth. Here we are at Earth, the largest of the 4 inner planets. It's the only place we know has a liquid water on the surface, as well as the only known place that's inhabited by living things. Our atmosphere protects us from incoming meteoroids, most of which break up in our atmosphere before they can strike the surface. Earth is only slightly larger than Venus, with just over 3.5 moons fitting in its diameter. Now to our last planet on our mission, Mars. And with that, our mission is complete. Mars is a dusty, cold desert with a very thin atmosphere. It has seasons, polar ice caps, weather, canyons, and extinct volcanoes. Mars is one of the most explored bodies in our solar system, and is the only planet we've been able to send rovers to explore the landscape. Mars is only as wide across as 2 of Earth's moons. And with that, our mission is complete.
So we're on Mars. If you want to put in the chat a review of that, a 1 or 2 word review, feel free. But we're on Mars. We're going to go out using that as a jumping off point for the outer solar system. We've made it to Mars, but that's not far enough. Let's blast off and tour the outer planets. You may know them as the gas giants, but they are so much more than balls of gas. The first stop on our tour is Jupiter, the largest of the planets. Jupiter is as wide as 11 Earths. You can fit more than 1,000 Earths inside. Giant storms like the Great Red Spot have been swirling for hundreds of years. Jupiter's outer layer is mostly hydrogen gas, but as you get deeper, that gas is compressed into a liquid hydrogen ocean. It has a solid core about the size of the Earth. Jupiter has 4 large moons and dozens of smaller ones. 3 of these moons are larger than our moon, including Ganymede, the largest moon in the solar system. The next stop on our tour is Saturn, the ringed planet. Saturn is as wide as 9 Earths. Like Jupiter, Saturn has stripes. These are different cloud bands, blowing east to west or west to east. Its most prominent feature is its rings, made up of chunks of ice ranging from tiny flakes to the size of houses, with a few the size of mountains. Our third stop is the only planet named for a Greek rather than a Roman god, Uranus. Uranus is as wide as 4 Earths. It is the only planet with its equator at a right angle to its orbit, probably due to a collision with an Earth-sized object. Most of the planet's mass is made up of water, methane, and ammonia ice, making Uranus more of an ice giant. Uranus's blue-green color comes from methane gas in its atmosphere. Our final stop is the solar system's other ice giant, Neptune. Neptune is also as wide as 4 Earths. Winds on Neptune whip methane clouds at speeds of 2,000 kilometers per hour, the same speed as a fighter jet. Along with these high winds, Neptune has giant storms like Jupiter. Its blue color comes from methane and other gases in the atmosphere. Let's head on back to Earth and tell others what we have learned. The outer planets are big, and they are definitely not boring. So that gives us a bit of an overview of the planets. Later I'll show you a couple of short films specifically about, actually 2 about Mars and 1 about Jupiter. Let's take a sort of a grand scale look at the solar system now. At the scale size, so how big are the planets and how far apart are they in a way that is easy to picture?
How big is our solar system? To understand, let's take a look at lengths around our planet and solar system. Washington State is 240 miles wide. Zooming out, the continental United States of America is 2,680 miles wide. Further out, the Earth has a diameter of 7,917.5 miles. The average distance from the Earth to the Moon is 238,900 miles. From the Earth to the Sun is 1 astronomical unit, common measurement in astronomy. We can use 93.71 million miles. The longest length for today is from the Sun to the blue ring, which is Neptune. This length is 2.78 billion miles. These numbers are hard for humans to comprehend, so let's scale down our solar system into lengths we do understand. And to do that, let's find a football field. To find the scale models, we need an actual length and a scale length. In this model, the Sun will be the size of a basketball. Our Sun has a diameter of 865,370 miles, and a basketball has a diameter of 9.55 inches. At this scale, Mercury, the closest planet to the Sun, will be just past the 10-yard lines, at 397.6 inches away, and would be less than 1/10 of an inch in diameter. Earth would be just before the 30-yard line, and would be 0.083 inches in diameter. To calculate scale models, you need to find ratios by using fractions. Place two actual lengths in the numerator and denominator, then set them equal to the same scale lengths. Here we have the diameter of Neptune compared to the diameter of the Sun, and our unknown, the scale diameter of Neptune, compared to the scale diameter of the Sun. Then solve for x. Make sure you label and double check all your lengths. Now take a moment and pause and find how many football fields away Neptune would be from our basketball sun. Did you do it? Well, Neptune would be 30,698.12 inches and would be just about 7.1 football fields away.
So that's probably one of the things that is most impressive to folks, just the scale, how spread out things are in the solar system. One thing that I like to do in the classroom, a lot of astronomy teachers like to do this, have something like maybe a basketball and have students predict how far away each planet would be. And almost always the students will line up all the planets within the classroom. And depending on the size of the classroom, it's possible that only Mercury would fit inside. So we did kind of a grand scale overview. Let's go to, and I actually wanted to switch my screen share from the full screen to the actual Worldwide Telescope app itself, because I think you might have been seeing the UR screen sharing thing the whole time. So let's look at a couple of the planets a little more closely. So two tours here about Mars. These were actually created by students in my Douglas Honors College class winter quarter. And these are students who had never used Worldwide Telescope before. So you may have looked at those tours, the first three that we saw. I made one of them, but the other two were made by students who are interns for the planetarium this last quarter. They had never used Worldwide Telescope before either. The students in the Douglas Honors College class had never used it before. So with just a little bit of practice and some hard work, you can come up with a really good overview of some aspect of astronomy. So here's a two-part tour of Mars.
Hello, and welcome to Mission to Mars Part 1. Let's get ready to blast off! Let's start our blast off at the Cape Canaveral Kennedy Space Center. Here we're looking at Launch Pad 39B, which is one of the several launch pads located at the Cape Canaveral Space Center. Here we're looking at a picture of Earth from the International Space Station. In order to leave the Earth's atmosphere, you would have to be traveling approximately 11.18 kilometers per second. This image shows a near prime position in orbit for an Earth-Mars intersection of spacecraft. This image of Mars has been censored due to its indecent overexposure. Here we have an image of Mars from Mars's orbit. This would be approximately what Mars would look like if you were an orbiting spacecraft. This pixelated blob of color is the landing site of the Phoenix spacecraft. This is one of the possible locations on Mars for human settlement. Thank you so much for watching the Mission to Mars Part 1. Check out Part 2 if you want to learn more.
And of course you want to learn more because that's why you came to this. So let us quickly go to Part 2.
Hi, welcome to Mission to Mars Part 2. We'll be discussing some of the most suitable areas for settlement. Phoenix Site is an area on Mars where we have already explored. It was the first landing site in a Martian polar region and is the most suitable area for life. The trench dug by the Phoenix rover is littered with ice crystals that have melted over time, as shown in these before and after pictures of the area. The North Pole is a formidable place to settle due to the massive polar ice caps that contain large amounts of water ice. Similar to that of the North Pole, the ice cap in the south contains large quantities of water ice. Although much smaller, the cap is still a suitable area for settlement. Gale Crater is a crater that has over time been gradually filled by running water. Though it is now mostly filled with minerals, there is still water buried underneath the sand. Korolev Crater is a large crater that is filled with ice, much of which is water ice, which could contribute to crops as well as consumption for the survival of those there. That concludes our tour. Thank you for listening.
And let's take a little bit of a deeper dive into Jupiter as well. So this tour about the Juno Probe, which was launched a while ago, a student who has since graduated made this tour. She was one of the first students, actually the first student to do a lot of work with the planetarium. And she's a middle school teacher now. NASA named its latest Jupiter spacecraft Juno after the wife of the mythological Jupiter. According to myth, Jupiter had many mistresses that he would hide from Juno, often in the clouds. Many of Jupiter's moons, including Io and Europa, are named after these mistresses. So what better name than Juno for the spacecraft that will pass by Io and Europa to study under the clouds of Jupiter?
Juno will learn more about Jupiter's composition, inner structure, and how its swirling clouds are connected to its dynamic interior, as well as how it's formed. The more we learn about Jupiter, the more we understand about the solar system and the conditions in which the Earth was born.
But why study Jupiter? Jupiter is made up of 13.6% helium, 86% hydrogen, and 0.4% of other gases, similar to the composition of the early solar system. It is the largest planet in the solar system and is thought to shield Earth from comets and asteroids. Juno was launched on August 5, 2011, and entered Jupiter's orbit on July 4, 2016. Looking at Jupiter's North Pole, we see systems and weather activity unlike anything ever seen on the gas giants. Along with many storms, the clouds are bluer in color in this region compared to the other parts of the planet. There is no sign of the latitudinal bands or belts like those that appear on the body of Jupiter. These clouds also have shadows, possibly indicating that the clouds are at a higher altitude than the other features.
If we take a look at Jupiter's Mik Region, we will see multiple bands. These bands are due to how each cloud blocks light, also known as opacity. These cloud bands correspond to global wind patterns similar to the trade winds or polar easterlies on Earth. However, this cloud band pattern is less noticeable on Earth because Earth does not have nearly as many clouds.
Looking at Jupiter at infrared or IR wavelengths shows that regions of the north and south poles have warm and even hot spots that have never been seen before. In this image, the brighter spots represent higher temperatures. Due to the high level of detail in the images, we will be able to learn more about how the auroras form and change over time. Astronomers have been able to capture the eerie sounds of the auroras.
Juno will complete her mission by making 37 orbits over a 20-month period. The mission will end in February 2018 when astronomers send Juno careening into Jupiter.
All right, so tour solar system. Let's get out of the solar system. So we've got this is a short tour actually made by a student who's taking intro astronomy this quarter, another student who hadn't heard anything about, anything about Worldwide Telescope before taking the class. And she's going to give us an overview of a couple of constellations and also an overview of her piano playing. So I tell the students that they should not be using copyrighted music. A good source for music that's free to use, you see the last one used a website called Ben Sound. I think that was from a few years ago. I think now you might actually have to pay for that music, but YouTube has an audio library of some music that you do have to pay for, but they have a lot of free music as well. So I encourage students to use the free music. There are also some free sound effects. So if you want creepy sound effects in your tour, you can add those as well.
And state, the United States, North America. These are all places that we call home. But beyond the beauty of our Earth, the universe leaves many interesting objects for us to look at. Today, we will be looking at two constellations. The first constellation is called Ursa Minor and is more commonly known as the Little Dipper, and this contains the star Polaris. This constellation also contains a dwarf galaxy known as Ursa Minor Dwarf Galaxy, but today we'll be focusing on the star Polaris. The star is known as the North Star because it is almost directly in line with our North Pole. Here is a close-up image of Polaris, the North Star. Zooming out, an easy way to identify this star is by looking at the commonly known constellation known as Ursa Major or the Big Dipper. If you draw a straight line from the end of the ladle-looking constellation towards the smaller ladle-looking constellation at that handle, you can find Polaris. Next, taking a trip to another constellation called Lyra. This constellation contains 9 stars with known planets, and one of these stars is called Vega. This star, in 14,000 years, will take the place of Polaris being the northernmost star. Vega will not be as close to our North Pole as Polaris is today, but it will still be taught as being the North Star 14,000 years from now.
So just a bit of an overview of the nighttime sky. Continuing on the constellation theme, we've got a couple tours, again, made by students from my Douglas Honors College class last quarter, and they are going to be focusing on the astronomy of Harry Potter.
Hello and welcome! We will be looking at two sisters in the Harry Potter series, Bellatrix Lestrange and Andromeda Tonks.
Since we don't have much time, we better hop on our broomsticks right away. Up!
We will first mention Orion, the constellation that holds our first hero, or villain, Bellatrix.
Orion the Hunter is one of the most prominent constellations in the sky, but the star of our show is none other than Bellatrix. Meaning female warrior in Latin, Bellatrix can be spotted on Orion's upper right shoulder. She's the 25th brightest star in the sky, overshadowed by Sirius, her cousin in the series. She's the 3rd brightest star in Orion, behind Rigel and Betelgeuse. Don't say that 3 times.
In Harry Potter, Bellatrix is the right hand, rather than right shoulder, of the major villain, Voldemort. She is a curse-happy woman who does significant damage to the series' heroes, killing many people, including Sirius.
Contrastingly, Andromeda was a kind soul in the Harry Potter series. She marries a muggle named Ted Tonks and has a daughter, the famous Nymphadora. Andromeda was disowned from her family for marrying a non-magical human.
In Greek mythology, Andromeda was the daughter of Cassiopeia and Cepheus. After she was sacrificed to the sea monster Cetus, she was saved by the demigod Perseus, whom she later married. Both versions of the characters married outside of their own race, so to speak, which is one of their commonalities.
Originally thought to be just Pegasus Beta, Andromeda truly is her own constellation. Astronomically, she is the 19th largest constellation in the sky, discovered by Ptolemy. Her stellar neighbors are the characters mentioned in the Greek myth. Her largest star is Alpheratz, named after an Arabic phrase meaning of the horse, referring to the Pegasus constellation that runs through Andromeda.
Well, that's the end of our Harry Potter themed tour. Thanks for watching.
Mischief managed.
So mischief isn't managed quite yet. We need to see Harry Potter and the Constellation Complications, Part 2. Again, from students in my wintertime Douglas Honors College class.
Hello and welcome to Harry Potter and the
Constellation Complications, Part 1 and 3/4,
where we continue our discussion about the different stars and constellations found in the Harry Potter series. Our first stop is not actually a star, but the constellation Draco. Throughout Harry Potter, Draco Malfoy causes problems for Harry in various ways. Some might say they were destined to be enemies. However, according to Greek mythology, Draco represents a dragon named Ladon, who is responsible for protecting the Hesperides nymphs, hence the dragon/snake-looking beast pictured here.
But Draco is not the last Harry Potter character to be immortalized in the stars. Our next stop is a not-so-humble star called Sirius. While Draco is one of the antagonists in Harry Potter, Sirius Black arguably plays the role of a father figure to Harry, supporting him throughout the story. Here, though, in the context of the constellation Canis Major, we can clearly see why the star is also commonly referred to as the Dog Star. It is also the brightest star in the sky, and is easily observable with the naked eye.
Finally, we come to someone very close to Sirius, his brother Regulus Black. In Harry Potter, Regulus starts out as a Death Eater, but redeems himself in the end by attempting to destroy one of the 7 Horcruxes. However, the Regulus we see in the night sky is much less evil and conflicted, at least as far as we know. It is found in the Leo constellation and is about 70 light-years away from Earth. While it is only the 21st brightest star in the night sky, its Latin name means Little King, a title Copernicus gave it to mark its importance in history.
And that concludes this edition of Harry Potter and the
Constellation Complications.
We would like to thank ConstellationGuide.com and Britannica.com for our information, as well as YouTube's free audio library.
See you next time!
And then last but not least, probably our most science-y tour is an overview of star formation. Easy for me to find that name because it's actually called star formation. And this again was made by a student who graduated a couple years ago. And actually I haven't been giving the names of the authors because some of them were done by more than one student. And I sent an email out, but only if I'd heard from all the students in the group saying it was okay to share their name, that I would do that. But Samaya Jalyar, she graduated, I think 2 years ago. But anyway, she was the first person that really got into making these tours. And here's her tour on star formation.
Welcome to a tour on star formation regions, where we will be looking at the brightest nebula in the night sky, the Orion Nebula and its neighbors, the Horsehead Nebula and Pleiades. First of all, what is a nebula and how does it relate to star formation?
A nebula is an interstellar cloud of dust, hydrogen, helium, and other ionized gases Star formation is a process that occurs within these clouds of dust, which are sometimes referred to as stellar nurseries. These regions are extremely cold, almost absolute zero. At such low temperatures, the gases become molecular and the atoms start binding together.
With that, we have entered the Orion Molecular Cloud Complex. Let's zoom into the Orion Nebula, also known as Messier 42 or M42. It is located south of Orion's belt, and as mentioned earlier, the brightest nebula in the night sky. It is the closest region of star formation to Earth.
As we zoom into the Orion Nebula, we see 4 bright stars. These are known as the Orion Trapezium cluster. It is a relatively young cluster, less than 300,000 years old, and is formed directly out of the parent nebula. This formation occurs when the molecular cloud breaks into dense fragments. These fragments gravitationally collapse, pulling in gas and dust and forming protostars. These 4 stars are classified as O and B type stars. Each one has a mass 15 to 30 times greater than our Sun.
Now moving on to the Horsehead Nebula, which is located farthest east on Orion's belt. The Horsehead Nebula is known as a dark nebula. A dark nebula is a nebula of dust and gas that is observable because it conceals light from other sources. Dark nebula are the main breeding grounds for stars due to their extreme temperatures at only 10 Kelvin.
Like the Orion Nebula, the 500,000-year-old Horsehead Nebula is part of a larger cloud complex called the Orion Molecular Cloud Complex. Moving away from the Orion Molecular Cloud Complex and toward the constellation of Taurus, we approach Pleiades. This open star cluster is also known as the Seven Sisters because the typical person can see the 7 brightest stars with the naked eye.
Pleiades, which is about 10 light years across, actually contains hundreds of middle-aged, hot B-type, blue-white giant stars. For stars, middle age is about 100 million years old.
And if Pleiades looks familiar to you, that might be because it's the Subaru car logo. Everything in our bodies was formed in stars, so the study of star formation is really just a part of the study of our formation.